Okay, so yesterday we were looking at converting Unicode represented in UTF-8 into the characters from the Unicode, table with the code points. And so if you recall the last class, we converted these hex bytes to binary and then stripped out the heading leading bytes that were telling us whether it was a leading byte or a continuation byte. We stripped out the extra bits, which left us with other bits. We put those back together into bytes, and then we're able to look things up in the Unicode table. And this turned out to be I heart this character and this character, which is Japan. Okay, so your dingbats, emoji, Korean, Ohm, all of these various writing systems would have a section of the Unicode table. They'd have code points in there somewhere. And once you have the number for the character, then you can go see what that is. So we can see from this, the main point, the main benefit of UTF-8 is that an ASCII character, or a character that would be in the ASCII table, will still only take 1 byte, which is good. It's looking here that this particular heart emoji anyway requires 3 bytes in UTF-8, and that these kanji, the characters here, these Japanese characters, each require 3 bytes as well. It's possible if they were coded in a system that was used only in Japan. So there's Japanese systems, for example, Shift.js is one. It's possible that you might be able to get each character in only 2 bytes. So it may be that UTF-8 appears to be a bit inefficient from a Japanese user's point of view. But you do have the flexibility that it's a standard that's global and worldwide. So we have 3 examples here. We have a capital A from English. We have A, the E accent here, which would be A. It sounds A, that's why it was chosen here. And then I believe the last character there is Hebrew. And if I looked this up, apparently that's called Aleph, that letter there. Okay? So we can see here in the different representations how this would look. So A, we know, is uppercase 65 in decimal, which is 41 in hex. In ISO 88591, which is what we might have been using, that is again character 65, 41 in hex. And in Unicode, it's decimal 65 or 41 in hex. So that's kind of the main point there, that the bottom part of the Unicode system will use the ASCII table, so they're interoperable. Okay? In 7-bit ASCII, that would have been represented as 401 in hexadecimal, and in ISO it's 401, and in UTF-8 it's 401. So that's the point there, pretty much. If it was in UTF-16, we'd be using 2 bytes to represent it, so it would have been 0041. And if it was in UTF-32, it would have been 4 bytes per character, which is 00000041. Okay? The E accent there, then the E, that would be an acute, that doesn't have any slot in the ASCII table per se. It doesn't. If we were to go back to ye olde ASCII table from 1960, whatever, it's not in there. In France, it would be somewhere between 128 and 255, somewhere in that range of values. In ISO 88591, which is what it would have been in, it's a position 233. So you notice that ASCII doesn't have a slot for that E accent, E acute, and it doesn't have a slot for Hebrew. Okay? ISO, this one here, does have a slot for E acute, but it doesn't have any Hebrew in it. Okay? In Unicode then, that's still taking up slot 233, which would be E9. Hello.
Sorry,
No bother. But the Hebrew character there is all the way up in the thousands. So it's in position 1488. So its Unicode code point is 1488. We can see then how they would be represented. Obviously there's no ASCII for it. In ISO 8859, it would have been E9. There's no position for the Hebrew in that. And then we can see here then in the UTF-8. You'll notice that if you look at the UTF-16 and the UTF-32, it's just a question of taking the value and padding it with zeros. So if it's the 4-byte one, you'll have leading 0 bytes. And if it's the 2-byte one, you have leading 0 byte for the E acute, but the Hebrew one uses the 2 bytes. However, the UTF-8 is more complicated, as you can see. It's using 2 bytes for each of these characters, but you have to do the jiggery-pokery in order to figure out the information in those. Because some of the data in those bytes is like metadata that's saying this byte is the first of 2 bytes. So the mapping isn't as obvious. To go from this E9 to UTF-16 to UTF-32 is easy, but to go from E9 to UTF-8, it's not as obvious what's going on. Okay, so you can see that for French, at least, UTF-8 is a bit inefficient because a French system could have gotten away with this character set here, ISO 8859-1, and in French you could do everything you want in 1 byte. But if you were to move to UTF-8, you're looking at using 2 bytes for the French characters where you would have had 1 before. So it would be interesting actually to figure out how popular UTF-8 is as a coding system in France. Because it seems to me it might not be that popular because it's making a lot of things twice as long as they might otherwise be. Whereas for Hebrew, it doesn't matter. For Hebrew, you're going to be looking at 2 bytes anyway, no matter what you do. And for Japanese and Chinese, maybe you were looking at 3 bytes anyway. Or we might find, as I was saying earlier, maybe Japanese could be done in 2 bytes, depending. Okay. What I want to look at now is how writing is done in Japanese, just as an example of how a foreign language writing system might work. Okay? It's tempting for us to think as English speakers that writing systems are the same pretty much the world over, except some writing systems have different letters. So French people have some accented letters that we have. In Hebrew, there are letters, characters we don't have, but there are letters. Polish has letters that we don't have in English. But, you know, there are letters. Some cultures have different letters. But it's actually can be significantly more complex than that. So I want to look at Japanese just as an example of how different it can be. Okay? So Japanese has a number of different kinds of symbols. And we'll look here at the different parts of a sentence here. So I've color-coded this here so you can see the different parts. So computer here is written this way, whereas student is written here, like this. In Japanese, the verb goes at the end. But looking at this, what I want you to see is that some of the characters in the Japanese part are very different from each other even. And I'll show you now what I mean by that. So Japanese has things, special characters that we call kanji. Okay? And these are very complex characters that way back would have been imported from China. So these would have been Chinese characters that came to be used in Japan. And each character, each kanji, has some nugget of meaning associated with it. So in English we only have letters, and we can combine the letters in a variety of different ways to make a word, and then that word has a meaning. But the marks we make on the page with the pen, we only mark letters, we only make letters, and then those letters combine to make a word. Each kanji has a meaning all by itself. So that combination of strokes makes some sort of meaning. Okay? You can combine different kanji to make more complex ideas, which happens in Chinese more than happens in Japanese. And actually, if you're looking up a kanji, if you see a kanji you don't know what it is, and you want to look it up in a dictionary, you actually, they order them by stroke count. So, you know, this one here would have maybe 1, 2, 3 strokes. This would have 1, 2, 3. In fact, actually looking at the way they're ordered here, even in the Unicode table, it seems to me they've ordered them pretty much by stroke count. You know, so we saw this here in the example we had. Of course, we don't have the numbers here anymore, do we? But we don't have what we worked them out to be. But this one here is that there somewhere. Anybody see it? I don't think it's there actually. Nope, can't see any of the ones we used before. Anyway, so this is just a portion of the Unicode set of code points, and these kanji are at these positions here, 4E00. You'd read this as 4E00, 4E01, 4E02, 4E03, 4E04, 4E05, 06, 07, 08, 09, 4E0A, 4E0B, 4E0C, 4E0D, 4E0E, and 4E0F. That's why there's 16 of them. So it's hexadecimal. So just every 16th one then is listed here. Okay? So that's how you'd read the Unicode. It's done in hexadecimal. So typically when you get the code point, you represent it as hexadecimal. You write it as hexadecimal. When you look it up, it's in hexadecimal. So, for example, this symbol here, this kanji represents an eye. Okay? So the concept of an eye is associated with this symbol. Now, how it's actually pronounced, it may be pronounced a number of different ways when you're reading it. But the idea of an eye is contained in this symbol. So in English, we have the letter E, we have the letter Y, we have the letter E. We combine them into the word eye, and that gives us that. But in Japanese, this combination of strokes, just this symbol here represents eye. Similarly here, this symbol represents tree. Okay? This symbol here represents pressure or force, for example. And this one here represents power or authority or influence. And when you combine them, those two ideas combined then give you the concept of coercion or overpowering or whatever. was making the same point here, but I can't actually remember what you get when you combine these two together. Okay. No, so that's kanji. So those are the most complex characters, and they're taken from the Chinese initially, although some of them are native to Japan as well. And I mean, the Japanese and Chinese meanings would have diverged over, possibly 1,000 years or whatever. Chinese uses only this kind of character. So in Chinese, to express the idea of a computer, you will have a combination of symbols like, it's something like, electrical adding machine or something, to give the idea of a computer. Whereas Japanese is significantly more flexible because it has different kinds of characters. Okay? This, incidentally, is the symbol for the sun. This is a tree with a little line, and that can mean the source of something. It's the root of the tree. It can be the source of something. So this is where we get the source of the sun. The source of the sun is Japan. So this is the symbol for Japan. The sun and that tree thing there is Japan. So you see that a lot. No. So those very complex characters are the kanji, and they have meaning unto themselves. We also then have hiragana. Okay? And you can see, looking at these, they're much simpler characters. So we can see this is hiragana. It's just a little loop there. This is a hiragana. It's just a one stroke and then down and around on top. So it's a much simpler character. So you can typically, when presented with text in Chinese or Japanese, you can identify the Japanese fairly rapidly because it'll have these simple hiragana characters, whereas Chinese will be only the complex kanji type characters. They don't call them kanji in Chinese. Okay? So they're native to Japan, and they don't mean anything by themselves. So they don't have a meaning. They're much more like English letters. You can combine them together to create words. But each is actually a syllable. So where we might use a H and an A for ha, there's a hiragana symbol just for that. So you could learn, for example, you could learn which symbols map to which sounds, and you could read hiragana yourself fairly easily without understanding what it actually means, of course. But you could read hiragana and do a fairly convincing impersonation of a person who was speaking Japanese if you could read that. So it's used for native words that don't have a kanji, or for a kanji that's really, really hard. That might be very, very obscure. So there might be a kanji for it, but it might not be something that most people know. Some of the kanji would be so obscure that most Japanese people wouldn't actually know what they are. They'd have to get a dictionary out to look them up. If you're writing an article in a magazine, you might decide, actually, that's too much hassle for my readers. I'm just going to go and use hiragana for that instead. But we typically see it for grammatical principles. So little words like of and things like that. So if we go back here, this hiragana here is no, but in this case it means of. So it would be a student of computer science, is what it's saying. So you could have a car of red. For a red car, you'd see that symbol there. So it means of, and it's pronounced no. Okay, so you have like a, I, U, E, O, ka, ki, ku, ke, ko, sa, shi, su, se, so, ta, chi, tsu, te, to, na, ni, nu, ne, no. So this was the no I was just talking about. ha, he, hu, he, ho, ma, mi, mu, me, mo, ya, there is no ye, you, yo, ra, ri, ru, re, ro, like that. Okay? So each symbol represents a syllable. So it's very different to English. Okay? Then we have Katakana, and that's very similar to Hiragana, but it looks very different. It looks much more angular. It looks much more more aggressive, almost, from a typographic point of view. And that's used for borrowed words or for emphasis. So in Japanese, it's quite common to use borrow words from English or indeed from other languages. So again, we have ka, ki, ku, ke, a, I, u, e, o, ka, ki, ku, ke, ko, sa, si, su, se, so, ta, chi, tsu, tse, to, nani, nu, ne, no, ha, hi, hu, he, o, mami, mu, me, mo, and so on. So again, we have the syllables, the same set of syllables that we have in hiragana, but with a different character, a different representation. And we use that for borrowed words. So this here is the Japanese word for computer, and it is basically ko and piu ta, which, if you have a certain fixed set of syllables in your language, that's as close to computer as you're going to get. Computer. So we have things like teburu for table. I noticed there when I got my new headphones, I splashed out and got new headphones for my phone. And in the Japanese instructions, it was talking about maiku, which was the mic. Maiku is as close as you're going to get with a certain set of syllables to mic. So where you see these kinds of characters, it's either for a borrowed word like computer, or it's for emphasis. So you see it a lot in manga, where it's like, oh my god, you know, that'll be in katakana, or if people are protesting, you know, done with Tokyo Electric Power, blah blah blah, it'll be in katakana because they're cross. So borrowed word or emphasis. Romaji then are Roman letters, English letters, that are used in Japanese. Interestingly, they have their own range of code points. So if you want to do an uppercase A in Japanese, you don't use ASCII 65 from the bottom of the ASCII table there. You actually use the section of the Japanese range of code points that has the A in there. And very often, actually, where you see it, it does look typographically quite different. They often use an unusual font. They tend to be quite wide, you know. So if you see Japanese text and there's English text in there, they may not actually be represented with the ASCII values or with the values you'd expect. They're repeated in the Japanese portion of the table. Furigana then is used to help children read kanji. So it says hiragana, 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 hiragana. This is kanji here, but if you're like 7 reading a comic book, you mightn't have learned that yet. You don't know what that is. So this furigana here is basically that kanji sounded out so you can read it. So the first things you will learn in school is the hiragana. So this is the actual grown-up way to write it, and then this is just put alongside for kids. So many kids' books will have hiragana written over the kanji. Okay. So we have a big mix here now So this is the Katakana which means I, me. This is just a piece of, this is kind of a marker, or kind of a spacer, a grammatical thing. This is computer, computa. This is science. No means of. This is the kanji for student. You notice there, look, the science thing there is repeated. So, and then this here is des, which is the verb to be, which comes there. So in here we have pretty much all of the different parts. So you can see that it's not simply a case of foreign languages having maybe more letters than we have, or different letters, or even characters that we don't use. There's a whole other way of maybe writing ideas that doesn't map to English. And so all of these things then had to be considered when devising a coding system that was going to be used for every language on the planet. Interestingly, if we were to Google Japanese semaphore, it's different, obviously, and they would have a flag combination for each of the syllables. So you could send your message from ship to ship, and the guy writes down the syllables and then reads it out. You couldn't have a semaphore that used kanji. There's thousands. When I asked you guys to devise your system for the zombie apocalypse with those traffic lights, we had letters, obviously, and numbers, but some people reserved positions in the symbol table for ideas, for whole ideas. One group had like a symbol just for zombies. They had babies as well in there, which was weird, but you could see how in that clutching there for efficient way of communicating, you really had kanji of a kind. And of course, now you know where emoji, the word, comes from. So they're like kanji, but for emotions. The G there is borrowed from kanji. And that's essentially what they are. I mean, each emoji contains in it an idea, And you might have a combination of emoji to create other ideas that aren't there. So like, food and happy when combined in emoji might mean something. But people don't, you guys don't use emoji that much, I don't at all. But you can see the sort of evolving along the lines actually of kanji. No. So there's a little detour, but I thought it was important for you to realize that when you are devising a communication system and a coding system, you have to take in all these cultural issues that you might not be aware of. What then about formatting? I mean, if you want to, you have something, you've got some characters in English, but doing things like in bold and italics and different colors, that becomes very complex. Let's just think about plain vanilla ASCII, where we've got 107 bits per character, 127 slots. How could we then account for, say, bold and italic? I mean, you could devise a system where you have 1 bit for bold and 1 bit for italic. And then it'd be up to like 9 bits per character. So if it's bold, the bold bit is on. But that becomes impractical then when you start adding colors and typefaces and sizes and other formatting stuff. That becomes, crazy inefficient. So that's where we have tags. So tags then are sequences of characters that provide information about the text. So essentially they're escape sequences where you say, okay, this isn't information that's in the message, this is information about what's coming up. So I want you to you're telling the receiver to like switch states in a way. So you could do something like, well, and then you might have like bold on, say, okay, turn on bold, bold off to turn it off. And so in essence, that's what we have then in HTML. So most of you are familiar with HTML, where you have tags. So you have like open bracket, or in this case, it's actually a less than symbol, but we treat it as a bracket. So like open HTML is saying this is the beginning of a HTML document. This is the beginning of the header / head. This is the end of the header. So you have special combinations of characters. They're escape sequences or tags. And so in complex documents then, where you've fairly complex formatting, you'd see that like in HTML and CSS, or in a PDF, you can have tags, markup tags. A Word document would have something similar. One that was very important in the past was PostScript. There's a thing called LaTeX, which is a system for marking up printed documents. It's still very popular with maths lecturers because HTML is very poor when it comes to maths. If you have an equation, you're summing x from 0 to 50, and this is in brackets, and this over this, minus b plus or minus 2a, blah, blah, blah. It's very poorly supported in HTML, but in LaTeX it's very good. So it's still used for that. In HTML, when you use special characters, there are some special sequences. So in HTML, where you're not using UTF-8, but just ASCII, you can say ampersand n tilde. For this n you hear, you can say ampersand e acute. E, there's an e missing here. It should be EACUTE semicolon. You can also say ampersand hash and give the code point. You find that a lot of Erasmus students would know the numbers of the characters that they're going to be using. Do Polish people do that sometimes? Do you know, like if you have a keyboard that just has English characters and you want, say, an L with the line through it, did you know the number? Yeah. So you actually know the code point of the characters that aren't supported by your keyboard, and you can just do, alt thingy thingy thingy, and it appears. So that's what you're doing. You're using the Unicode code point, unbeknownst to yourself. Okay. Another thing then we haven't addressed at all is the actual shape of the letters. So even if we have agreed that an uppercase M is what's been received at the receiver, we haven't considered the actual shapes of the letters. And really there's a whole module in that. We're probably not going to look at that, but there are 2 or 3 different schemes that are widely used for representing the shapes of the letters. So if you know you've got an uppercase M and a U umlaut, how do you actually represent that on the screen or on the page? How do you describe the shape of the M? That's a whole other thing. We're probably not going to look at that. If we get time and I get myself organized, we might look at it towards the end because it's interesting, Okay. Any questions on any of that? So a bit of a detour now today. I don't anticipate you being presented with some Japanese text in the exam, for example. But now you can at least, walking past, maybe spot the difference between a Japanese restaurant and a Chinese restaurant just from looking at the menu. So if you go to Wagamama, for example, you might see hiragana and katakana, whereas if you only see things that look like kanji, it could be Chinese rather than Japanese. Any questions on any of that? Okay.